Hi, everyone. This is Emma from Circle CI. Thanks so much for joining the webinar today. We're really excited to have Daniel here to talk about setting up Circle CI workflows for your Salesforce apps. Just a quick bit of housekeeping before we get started. You can ask questions at any time in the Q&A section of the Zoom webinar. Daniel will stop periodically and answer those questions for you. We're also going to record this, so if you have to jump out a little bit early, no problem. We'll post it on YouTube later, and I posted the link there in the chat, and we'll also message it out at the end of the webinar. If there's anything you're wondering about, please do ask questions. We would love to answer those. And with that, I'm going to turn it over to Daniel and let him get us started. We're really excited to have him today to tell us all about using Salesforce and Circle CI together. Great. Thanks, Daniel.
Yeah, thank you, Kim. And hi and good evening to all of those attendees. It's evening on my side of the ocean, probably late morning on your side. So good morning, lunch and learn for you in America. Just a few words about me. I work as a technical architect for a Salesforce SI partner in Germany. The company name is DIA, Die Interaktiven. It used to be DIA Interaktiven in the past. Now turns to be DIA as we are rebranding. I'm a co-leader of the Frankfurt User Group in Germany, and if you'd like to follow me on Twitter at Stangomat. My blog is blog.danielstange.de. From time to time, whenever I find time to post things, I'll drop a line there. You might have noticed I'm not a Circle employee, and I'm just I used to turn to be a customer in late 2018. I had some experience in continuous integration, and all of them were not really good ones. So probably my turning to Circle CI actually was kind of the last shot I'm going to give that topic, because I just was unnerved with the hassle of setting things up, and eventually I found it quite easy and understandable how to do my flows in Circle CI. And I want to pass on some of these learnings that I had setting up my Salesforce DX workflows in Circle CI onto you. So that's probably, if you're deeper in Circle CI, there might be a lot of content that you already know. For all of those who want to get started with continuous integration on the Salesforce DX side, that's probably the audience I'd like to talk to. I targeted my presentation on those guys who want to start their workflows on Circle CI. We can also discuss more sophisticated workflows later on. But with that, what am I going to show you today? I'm going to talk a bit about prerequisites for a Salesforce DX-based workflow in Circle CI. Before we dive into the configuration file, I'm going to talk about why should you care about CI at all. I'll have a quick detour around the basics and concepts of continuous integration and the bits and bobs of a configuration file. And then I'm going to design our workflow, our very first workflow to build an app that really deploys to a target org. After that, we're going to run our workflow and see if we can fix some deployment errors that we get. We'll probably get some. I know I will get some. And I want to add some QA measures so that we have a quality gate for our code. After that, and after our first application is up and running, I'll give you some ideas where to head next and how to get your projects organized. So what I'm going to show you tonight is a sample project that I have open sourced on GitHub. So browse to GitHub DSTDIA Circle CI webinar to find the source code, and you can check the build information and the commits that I do later on. If you want to try my configuration, just check out this configuration. So first off, what do you need to run your Circle CI based workflow with Salesforce DX? You will definitely need an org that is enabled as your developer hub. The prerequisite for Salesforce DX is a trial org, an enterprise edition, or your production org, enterprise edition or up, or any customer org where you're building, for which you're building the your application. You just have to enable the developer hub functionality, and then you have to set up a permission set to enable your developer hub. That's well documented. So if you're starting with Salesforce DX, make sure you have a developer hub and enable the feature for you. You will definitely need a distributed version control system. GitHub and Bitbucket are the ones that are integrated with Circle CI as not just for as a code repo, but also as a single sign-on measure. So if you have a GitHub or Bitbucket account, you can straight log into Circle CI straight with that. And to try out the functionality from the command line and develop on your computer, you need the Salesforce CLI. That's a package that you download and install when you download Salesforce DX to your computer. You really don't need it actually in your CI workflow because everything will run in the cloud. But to get an understanding of the Salesforce CLI, you should have it on your computer, because what a CI workflow basically does is run the code and run the command line options that you have in your configuration file. So shorter links to access my repo is bit.ly/SFDX Circle CI. And if you have your Bitbucket account or GitHub account at hand, you can sign in at Circle CI to get your own account there. So why should you actually take the hustle if you have a running deployment workflow for Salesforce? I assume that most of you actually do Salesforce development and Salesforce deployments. Deployments can be really painful if you do that by change sets. They can be a bit easier if you deploy via the metadata API or any tools that help you promoting changes to production orgs. But basically, most people that start working on a Salesforce platform just build in a sandbox and then push it to the production org somehow. And the thing that you want to tackle actually is the somehow in pushing changes somehow. You definitely need, if you want to build enterprise applications, you definitely need a structured process for your changes. And that actually means make it repeatable. So every time you run the same process, it should have the same results if the source is the same, if the contents are the same. It should be automatable, because you actually don't want to collect all the changes that you made and bundle them into change sets or metadata bundles. And it should be transparent. It should be audible. You should have a chance to see who did what and which test you actually run on that. And once you have to have that change process somehow in a structured way, you will run your change process in a way that you'll find bugs and flaws in the things that you're pushing quite early in the process. Ideally, you don't accept any changes into any of the main branches of your repository without testing it for basic bugs or test coverage. As soon as you have the hassle out of deployments and out of building your Salesforce applications, you can start to deploy more often and earlier. And if you deploy more often and earlier, if you promote usable software early, that's closer to an agile or iterative approach to building Salesforce applications. Automation actually reduces the effort that you have in building your bundles and change sets. And if you can make sure that your deployments are complete, if your deployment packages are complete, you will reduce the failures that you receive on deployments, and you will reduce the trouble spots that come from deployments, be it field level security missing, some forgotten component, etc. And eventually, if you're in a process that your code is being tested at all steps, you can also start to have quality assurance on all these steps and make sure that everything is tested against your certain acceptance criteria that you might have in terms of code quality, or another important thing is to fill description fields wherever they are in Salesforce. You can not just check code quality, you can also check for completeness of metadata. I will show examples later and give you some ideas what to do with the metadata that you have in your repository. So to put it in 3 words and in 3 rings probably that work together, there's a development lifecycle that you want to follow. There's test automation that you want to have in your build process, and there's deployment automation that takes the hassle out of deploying things to the on the Salesforce platform. So you put in some effort to reduce the effort that you have with deploying your code. And overall, the idea is increase the quality of changes that you make on the Salesforce platform. After all, it's building usable and high-quality software, even though changes on the Salesforce platform might be declarative, might be just point-and-click things. You still need to have a focus on quality, because if you don't focus on quality, things will break in production, will destroy data, and actually, and after that, if you break in production, there are that leads to sad customers, sad end users. The more and better you test, the less failing deployments you will get. So why did I decide to go for Salesforce DX, and why did I decide to go for Circle CI? Salesforce DX actually was announced at Dreamforce in 2016, and as soon as I heard what it's going to come, I realized that there's something coming to the Salesforce platform that is really close to a modern and high-quality development tool chain and experience for Salesforce developers. It really looked like Heroku pipelines, and it turned out to be exactly that. At the same time, I found out about Circle CI, and what I really love about Circle CI is that it integrates seamlessly with Bitbucket or GitHub. I used to have accounts on both. Our company repos are on Bitbucket. My open source repos are on GitHub, and I can integrate everything with my Circle CI account. I use either of them for login. I can switch between my repos and the ones that I do for work, the ones that I do for fun and for open source projects. And for open source projects, you'll get a really powerful a set of containers with Circle CI. For closed source, at least the entry tier and the first container is free. The rest of them will be paid. And having failed to really build good tool chains on Bamboo and Jenkins, I really can say that it's easy to configure, because everything is in that one config YAML file. So for me, it was clear that I'm going to build cloud software by using cloud software, and that's not just a good recursion in that sentence, but I think that's that's the right approach to tie everything together. That's on in the cloud, and whenever you need something else, be it a quality gate, which I realized here with Apex PMD, but can be done with Clayton IO as well. Whatever you need can be tied in just by integrating another cloud product, and that really gives me the flexibility to choose build my tool chain just as I develop the thing. So what am I going to do with my application? I built something locally and in a Scratch org, and I'm ready to deploy this to production. But how do I do this? There's an empty org here, and I've committed to my GitHub repo, but nothing ended up in my org yet. Probably I was doing something wrong. Let's have a look at the commit that I made, and you can see there's well, this there used to be a check mark in the morning. All the rest didn't work. Circle CI gave me some clues what actually happened, and I can see that the tests failed and the PMD check failed. So I'm going to dive into this and trying to fix this as we're going through my slides and my presentation. If I click on details, Circle CI will guide me to the web interface, and you can see the output of the tests coming in here. So there was actually something wrong with my tests. The assertion failed. So let's look into that assertion and fix that assertion and start the build while I move along. The assertion here is obviously broken. My method will just reflect the argument that I passed in, so it should be something. So if I assert against something, something against nothing, it doesn't work. So I'll fix that assertion so that the test actually will pass it, and then I'm going to commit this thing and push it to the repo to start another build. Just so the build is now queued, and we'll get feedback on this later on. Let me just dive in what's going to happen now. What happens now is an orchestration of Salesforce DX commands. You should know, if you're already using Salesforce DX, you should know them. There's a command for creating a scratch org. There's a command for installing the source into that scratch org. There's a command for running your tests in that org. There's the force : source : convert to convert to the metadata bundle format, and there's a command to deploy to the target. We will need all of them later on. Now, if you put that in the orchestration for CI workflow, you will have the overall layer of the workflow. It just describes what's going to happen and when it's going to happen. It will break down into a job or more of them. That's actually a set of commands that will run in one container. And each job consists of one or more steps. That is actually a collection of commands to execute. It's not that simple always. It won't be just one layer, but a few of them. So you'll have something like this, a complete workflow that orchestrates and goes through a number of jobs, which also will break down into a number of steps. And this is what's happening here currently. My container worked through a number of steps. It built an environment. It authenticated the Dev Hub. And again, one of the containers failed, but let's look into that later. This one is still running, and this one was successful. We fixed the test, but we still have a failure. So let's look into that failure later, because I kind of have an idea what's going wrong. When I started to build my flow, I kind of collected some thoughts about what should happen and when and why. And regarding Salesforce DX and you always have to make a decision which environments you will need. There are persistent environments. We all remember the sandboxes that we had in our development flows in the past. We all know about scratch orgs, which are orgs that you will build whenever you need one. You can use them to test or to develop something, and you will pull it into your repository after that, and just ditch them. And scratch orgs are not there to be to live longer than 30 days. Most of them live just a few minutes, like the ones that I use in my workflow. So there are decisions to make when I will when to turn to a sandbox, or when to turn to a scratch org. And after all, we try to put that in the structure of a config file for Circle CI and map the requirements to the items in the configuration. So, which environment should you choose for a step? From my opinion, actually, is that whenever you need someone to access the system that you built from your repo, it's good to choose a sandbox. So in my flows, typically there are scratch orgs to run tests in. Scratch orgs for everything that's somehow automated, and whenever I want to pass on something into UAT or business acceptance testing or integration testing, I will push that into a sandbox with an ERP system attached, with users set up in these environments. So whenever the users are involved, whenever something has to be tested in the user interface, I typically go for a sandbox in my flows. For all the things that run just once, fire and forget, I choose a scratch org. And especially for the most important thing in your project, scratch orgs are just the thing to go, and that's testing in isolation. I want to build my project completely in isolation and see if my project itself is valid and will build properly. So that's one issue that I'm going to fix with my my setup. Also, I'm eager on verifying that the code quality in my repo is high and follows best practice. And only if both things finish clean, testing in isolation, and the quality gate for my code, I want the commit to go into the target org, and only if we have a commit in the master branch, and not for the other branches that I might have in my repo. So what I'm going to do in these steps is I will definitely need the Salesforce CLI, because that's not in this in the Circle CI containers. I need to connect to my Dev Hub, which is the org that authenticates me against the Salesforce DX for Salesforce DX usage. I need a scratch org indeed, and I want to push and test in there. I will need an installation of Apex PMD and run the tests. And I finally have to connect to the target and deploy if we are in master branch. So I just wrote that down to build a kind of metrics of what steps to take when. I gave them some names. And looking at this chart, there are some things that are in all columns. So I chose to prepare the Salesforce DX environment just once, and then use it for all of these steps. And I've checked that the deploy task job should only run when we're in master branch. So this is for orchestration later on. So let's look into that setup job that I built. This is the first part of my configuration file, and you can see that I choose an environment to run in. That's the first line that says machine equals true. And I set a working directory and some environment variable. You can set environment variables from the straight from the job, as I did here for the command line interface download URL, or you can set it in the project settings. So whatever you want to store in terms of credentials, you want to store these in the environment variables. And what I stored in the environment variables for my project here is the SFDX URL. It's actually a pre-authenticated URL that your jobs can use to log into an URL. Other ways to authenticate are certificate-based or username and password-based. You can choose whatever you like, but I find the new way of using the Salesforce DX URL with the authentication right in the URL is the simplest one, and it doesn't it saves a lot of time in the workflow. So I chose those. The rest of the first job is basically housekeeping. There's a step that downloads the command line interface, and a step that creates some folders to store data in later. And there's a command that I run to authenticate the Dev Hub and set the alias. So that's the end of the first job that I run. And there's something to keep in mind. Each job runs in its separate container, and it doesn't know about the things that you did before. So to persist something from one container to the next, you have to use one or more of the ways to persist data in Circle CI. So I choose to create a workspace, and the persist to workspace command sets up this workspace and saves them to disk, kind of. So I created a root. I assigned some paths to that, and the same goes for the log files. If that come from installing the Salesforce DX command line. If something breaks, I need to access the log to see what broke, and I can't access the log in the container because at the time I want to look into the log. The log file won't be there, and the container won't be there any longer. So to get the log files out of the container, even to look into them later, I use the store artifacts command. Store artifacts actually saves the contents of one folder and a file to a specific destination where you can access them later. So to wrap up persistence, there are four ways to persist things from your jobs. I told you about the workspaces that act as kind of a drive, hard disk, or whatever name you choose to store data that you have created in one step and one job, and use them in another job or another step. If you use workspaces and rely on the paths in those workspaces, you have to export the paths of your that you use to your current container so that you can actually access the command line. You'll see that in the next steps. If you want to store something that doesn't change often and will be downloaded all of the times, you can use a Circle CI cache to store the data in. As it is with all caches, they might survive, but they don't have to survive. They will live longer than the single build, and if you're lucky, the cache from an existing build will be still there when you run the next build. So you can save some time downloading things or preparing things, building complex libraries, etc., and put them in the cache. You can use wildcards and tokens in the cache so that you can build caches for specific branches or specific versions that you build. You can read them from the environment variables to use specific caches for those branches. And You can you have specific functions for jobs and steps in your job for storing artifacts and test results. Those using artifacts and test results actually pipe the output into separate tabs in your in the console here. For example, if you store the test results, you will have them in this tab here and can access the test results from your build outside of that container. So these are the four most important types of persistence that you can use in your workflows. The thing that is most helpful for my config is the workspaces. I use the cache to store the current install of Apex PMD in them, and I use artifacts to pipe out log files and PMD results and test results to store the Salesforce test results. Now let's go into the test execution job. This is the job that actually tests if the thing that we coded can live in the Salesforce ecosystem. You know that everything that goes into a production org has to be covered by at least 75% of those lines by unit tests. And if you're a serious Salesforce developer, you don't do just tests for line coverage, but also but you do serious unit tests. So everything that you build should be covered by unit tests that test the functionality. And if you're doing test-driven development, you'll write the test even before you start with your code. So you really want to run your tests whenever you move data, whenever you check in code into your repo, whenever you move your code in a new environment, and you want to see the test results for your unit tests. So that's why we're using persistence here. And if you're following along in my repo, if you're working on my repo, you could probably try to add a Lightning testing service to my test flow, just to see how unit testing for Lightning components and JavaScript code in your org will do. I won't do this in my job now, but it's something that you can try on your own later. So again, back to the config file, and it does just what I explained before. You can see that it starts with the checkout. Checkout pulls the contents of the repo into the container. And the first thing that I do is attaching the workspace that I created in the first job to my new container. And after I attach the container, I want to use the path for SFDX, so that I run the SFDX command later. So I exported a path into that container that points to where the Salesforce DX command line interface is installed. And then I'll create a fresh scratch org. That will typically takes a few minutes. And you can see that I'm using the org name hub that I created just in the other container. So everything is transported over by attaching to the workspace. And then the thing, and it's just plain creating the scratch org, creating some directories to store the results for the tests, push the source to the test org, ask the Salesforce DX command line interface to run the tests in the org and output them in a JUnit format, and store the test results in the designated folder. And after I'm done with testing, I will delete the scratch org and I push the test results into that into the place in Circle CI where the test results should be stored, and that's the store test results command that attaches the folder test results to the container that I run. Okay, so just so a question that is that's relevant for the configuration file that we just have here. That's actually the question is what is the Salesforce DX command? What is the environment variable SFDX CLI URL? Let me show that in the IDE. I used the DX CLI URL to know or tell the flow where it should download the Salesforce DX command line interface. The containers that I use, you see it's the most simple one that I use, machine equals true. They don't have Salesforce DX pre-installed. So the first thing that I do is assign the value, the URL of the Salesforce command line interface to this environment variable, so that I can use it later on here. Currently, this is hard coded in the config file, so you could also use the put the URL here straight away, but that can be done through the environment variables of your project. Okay, I'll go through that JWT question that you have later, because it will break the flow a bit now to talk about the separate, the specific ways to authenticate. I used JWT before I switched to SFDX URLs. All of them have their good things about them and things I don't like so much. So we can I'll discuss that later on. Let's just quickly go into the deployment job. To see how we push things into a persistent org. This can be a sandbox for integration tests, as I said before, or the production system. A deployment job actually needs something else, because we can't deploy on the metadata API by just pushing our Salesforce DX source format. So we first have to convert to the metadata API format. And after that, it's just deploying the metadata and run the tests that we want to run in that environment. I see a difference here between running the tests in your Scratch org, because the tests that you run in your Scratch org are actually the tests that are in your project. If you deploy the metadata, you want to run at least the local tests for that org, so that you see how your the development that you bring in behaves in the org, or how the tests of the org behave with your development. The paradigm that is built into Salesforce DX is that you compartmentalize your source, so that you have smaller units of defined as a project. So you don't have less metadata. And we probably can discuss this later, why Salesforce DX and Circle CI-based flows can be really different from what the old-fashioned Jenkins jobs that most of you probably have in your projects. You probably know this by now. How I do this, again, I'll check out the code. Yes, that's redundant. I could do that for all of the containers in just one step. Excuse me for being redundant here. I took the liberty to check out the code in that step as well. Again, I attach the workspace and export the path to the command line interface, and then I authenticate the deploy target with that Salesforce DX URL that I have in the environment variables of my project. And finally, I convert the source. That's a force source convert command. And then I deploy the metadata bundle to that target org. And that's the force mdapi deploy command. And I choose to run run all local tests. and see the results there. As we're getting close to the end of the config file, let's have a look at the section in the Circle CI config file that's called workflows. You can see that we have a few commands there how to orchestrate that things, and it reads as follows. The first job to run always is the SFDX environment job. After that, we will run the job tests, and that requires SFDX environment, set up as DX environment. There's a second job that I didn't tell you until now. That's called PMD check, and PMD check requires set up DX environment, but it doesn't require tests, and that's something that that helps us to save a lot of time in the flow later. And after that, there's the deploy job that has something applied to it that's called a filter. And the filter is on branches. And the filter is only, you can filter positively and negatively. So I choose to positively filter on master. And that basically means that the job deploy only runs when it's the commit affects the master branch. And the deploy job requires the tests and the PMD check job to run. So what we have here is something that allows, if you have enough containers at hand, to go into parallel, because tests and PMD check can run in parallel because they just require set up the X environment as a parent job that has completed. Once set up the X environment has run, it can run tests and PMD check at the same time. But then, if you're on the master branch, it will wait until tests and PMD check have completed before it will start the deploy job, but only if we're on master and if both tests and PMD check have completed successfully. So we'll run that flow again, and we try to fix the one failure that we have. So what I did here is I built a trigger, and as you can easily see, it loops through the contents of the trigger new context, and it runs a SOCL query in that loop. So that's a violation against an PMD rule, and that's no SOCL in loops. There's if you think deeper about it, there's another violation that we can see easily. Because one of the best practices that we want to follow is we don't want to have logic in our triggers. So this is the second rule it violates. The third one isn't that obvious as the other two. The third violation is that that we should always check for the permissions to actually read, create, update, and delete that object, and if check for field level security. So I don't know this because I wrote this piece of shitty code, but also because I ran Apex PMD in my third job, and it stored some artifact about what it found in the code, and gives me that feedback here. It tells me where the problem is, and it tells me what the problem is, and it will explain if I click on that why this rule is as it is. You will probably need your own selection of rules and the gravity that you give all to the to each rule. So the PMD configuration isn't really what I'm going to talk about a lot today. Just let me show that I put the PMD config in a folder here, where here is my rule sets. The rule sets is actually the very basic thing, and my code will be validated against this. So let's clean up that trigger here. I just comment this out because it's all of it is crappy code, and we don't want to have this. So let's commit this, and let's push this. And for the last time this evening, my job should start just in a minute. We'll see the results later, and we will see the results in my Slack channel. I connected the Circle CI, my Circle CI job to my Slack channel, so I'll get the information of builds that failed or builds that succeeded in Slack. That's quite easy to configure for each project, and you see the Setup DX job has just started. While I guide you through the PMD job, I decided to add a quality gate, and that's not just for the demo, but also for my team here at DIA, because I think that we should really improve our code quality by checking against a specific rule set that we want to follow. I typically do this with Clayton because it's just easy, and I like the idea how Clayton is built. But for this use case, I embedded Apex PMD because Apex PMD is free. It's configurable, it's easy to extend, and it's actually a really cool project that that a bunch of people put their energy into building rules to help others to have better code. So I really find that Apex PMD is something that should be supported by giving them exposure in the community. It's free, it's community maintained, and we should support this as well. Quality gates in general act by just blocking merges or sending out warnings whenever a violation occurs. And the things that we have to automate to build a quality gate is just download PMD, add the rule sets to our repo, and scan for violations. And that's what we do here. For this, to use PMD, I know the releases of PMD don't happen that often as the latest Salesforce DX command line. So it makes sense to cache the installer. That's what I do here. I prepare, don't just attach the workspace with the Salesforce DX command line interface, but also I restore the cache that is probably there. And if it's not there, nothing will happen. Again, I prepared the path for Salesforce DX, and then I downloaded and installed the binary for PMD. PMD actually runs on the metadata format of Salesforce, so I convert this thing to a metadata bundle, same as in a deploy job, and then I run PMD on that. PMD has quite a number of configuration options. It's highly configurable in the output formats. I chose the simple HTML output. I decided to create a cache so that everything that has been checked before and didn't change since the last check is not checked by PMD again, but it also always tries to validate the result against the cache. And I put the PMD log in the artifact folder that I prepared. So after I ran everything, I saved the PMD cache. The PMD cache makes sure that the installer is cached, that the analysis cache for Apex PMD is being built, and I store the artifacts so that I can access them in the web console. And that's what I do to quality check the steps here. And let's see if we have. Yes, there we are. You can see the tests have now passed. the PMD job just finished and didn't block the merge. And because we are in the master branch, I know I shouldn't push straight to master, but I did that. Because we're in the master branch, the deploy job just ran and deployed to my Salesforce org. And let's see if I refresh the Apex classes. You can see my sample class has been installed in my Salesforce org. So we reached the goal of building that small project that I created for you, and push it through the quality gates, push it through the tests, and finally install that in the org where I wanted to push this. So we reached the goal, and we can look at the next steps that you could do. The first thing is really something some kind of switching the philosophy from the old development model in Salesforce to the new development model in Salesforce DX. If you want those projects to be successful, you have to break down the metadata, the monolithic form of your metadata, into smaller projects and smaller functionality. That's really, really hard. My teams are struggling a lot to build smaller components, have smaller projects. So really, that's something that's really tough. But the things that you can do with the smaller things, smaller projects and smaller components that you have, are just cool and amazing. You can have a look at the Trailhead Apps Easy Spaces project that has a really nice configuration to build second generation packages to build installable bundles of those projects. So that's a really nice configuration done by René Winkelmeier. You know him of being the driver of a lot of Dreamforce and TradeX demos, and that's really amazing work that he did there. Also, I want to give a shout out to Sandor Knapp, a Salesforce MVP, who started and to build something that automatically breaks down your unit tests and creates test suites on the fly for all of the containers that you have. It's just simple. He just goes to check whatever tests you have in your project, divide them by the number of containers that you want to run on, and just don't run 40 tests in one container, but run 10 different tests in 4 containers. So that's a really great idea to save on build time, and it really helps if you build packages. So check out these 2 repos if you want to see something really cool. And with that, I want to just point out again where you can find the sample code. That's github.com/dstdia/Circle Cl webinar. You can find the complete project and the commit history that we just did tonight or today. And I want to thank you for sticking with me through that hour. And I'm going to look at your questions now, and happy to discuss things with you. So let's see. The first thing actually was the question, can the target org be a sandbox? And that's definitely a yes. The target org should be a sandbox indeed, because in a real repo, in a real life situation, you really want at least a UAT sandbox for customer sign-off or business user sign-off in the development flow. So to whatever target org you choose, it can be a persistent, it can be a production org, and or a sandbox. It just makes a difference in the ways you address these orgs. You know that in Salesforce DX you can just run the force:/source:/push command, and you can't do that with persistent orgs like sandboxes or production orgs. So that's the difference that I make, and the rules that I have for choosing persistence org is that I don't want to push any code that has not been tested before into a persistent environment, because once you spoil the sandbox, the only thing that you can do is run a destructive change set or refresh the sandbox, and you don't want to do either of them. So I first test the code against the scratch org. I can ditch them. I can delete it as soon as it failed. And only after it passed the first quality gate, it should go into a persistent org like the sandbox. And only if it got signed out there and has passed integration tests, it should go into a production org. So the next thing that I did is the question about JWT. I used to do JWT with a connected app in the org in the past. So if you look at my a presentation that I held in the past, just a second to load that project. Hang on, the ID just froze. There it is. I ran the whole line, lot of steps that you need for JWT authentication. So I checked out. I converted the environment variable that I had in the project setup with the hub key into a key file. Then it rendered an OpenSSL key, and then I ran the auth JWT grant with the client ID, which I pull from the environment variables, the JWT key file that I pull from the local storage, the username that I pull from the environment variables. So that's a lot of steps that you have to run. So Salesforce DX actually gives you the option to get the SFDX. Oh no, it will update my CLI. If you output the org details from your for any of your Scratch orgs or connected orgs that you have connected to your Salesforce DX environment, you can call for the details for that org, and in the details you will find something that is the Salesforce DX authentication URL. In the SFDX authentication URL, there's an authentication token that will allow you to connect to that org. So running without that server key on just that Salesforce DX authentication URL is super simple because you have just one environment variable. You don't have the steps to create a key, create a connected app. The only thing that you have to do is authenticate the URL on the command line first and create that login URL. I can probably show. Oh yeah, there's one. So let's see if we can go into the details. SFDX force force:org: details -verbose, and the username should be this one. See, I don't know my DX properly. It's force:org/display, not detail. It's not this, but this. And you can see the the authentication URL here. So that's a simple way. You just store this in the environment variables, and you can use this pre-authenticated URL anywhere. Oh yeah, good question. Vivek asked if there are any downsides to the URL login approach, yes, these tokens actually can expire, and if they expire, you cannot use the URL again. So it depends on if you on your settings how early this token will expire. And if you frequently use this URL, the token won't expire in just the development lifecycle that you have. But actually, yes, you're right. The token can expire. I don't know I don't remember the exact number of days that it lives. So if you just push something from time to time to that org, and if that time to time period actually can be a number of probably weeks or months, there's a risk to that URL-based approach because the token might have expired. And if that's an org where you have where probably you could revoke your own tokens and could probably change your password, etc. You could be deactivated in that org. This org will force your token to be expired, and then this approach won't work. Then you will be safer if you use a pre-authenticated connected app and just sign in with your certificate. So you build a hex key. You build your key from the hex key that you store in your environment variables, and there you go. So that's actually that's probably a strategic thing that you have to plan ahead to build your to build those connections. So, are there any more questions that I could answer? If not, please feel free to connect with me on Twitter. You can reach out to me via my email, and my blog address is just my name, Daniel Stange, in just one word, blog.danielstange.de, and you can reach posts on the topics that I just presented from time to time. With that, I can give it back to Kim for the final words, probably.
Great. Daniel, thank you so much. And thanks everyone for joining. Found this super helpful and interesting. Again, we'll send this out via email after the webinar, and we will also post this on our YouTube channel. I shared the link to the YouTube channel in the chat right at the beginning of the webinar. So with that, we will end the webinar, and thanks all. This has been great.
Thank you, everyone. Bye-bye.